In the last two presentations, we have established that any structure or building lies on a particular location, and its construction plan or its life cycle is affected by its surrounding, or its existence affects surroundings. Therefore, we have seen that how to use GIS in modeling surroundings. And in the last presentation, we have seen that how to model surrounding in GIS and how to place the model of a particular building that is to be constructed or facility to be constructed in its surrounding. So when a building has its surrounding, there are so many analyses which are possible. So briefly, we will discuss few of them here. If you see, there is a BIM model of the building that has been prepared and that has been placed in its surroundings, and surrounding has been prepared in GIS. So once we have a surrounding or locality of a particular facility, then there are so many GIS based analysis which are possible. Among them, basics. On the virtual model itself, we can measure horizontal distances, we can measure elevation, we can measure slope, we can measure directions. This virtual surface helps in site planning also, land use planning. There are other analyses also which are possible. So we'll discuss one by one. First, location-based selection. So location-based selections help in selecting a facility based upon its location with respect to other existing facilities or utilities. Other type of analysis which is possible, area-based selection. So in this area-based selection, it highlights all facilities or components of a facilities which lies within a particular distance from a particular location. At that particular location will be building site or something else depending upon the query. So in this area-based selection, a buffer of a particular distance or specified distance is created around a particular location, and what fall within that buffer zone, that those features are highlighted. If we have that 3D surface model, other things which are possible, even without going to site, we can calculate projected area on a particular surface, or even we can measure surface area, we can measure surface length also, or even sometime volume between the two surfaces. Surface area is measured along the surface, and if we see the difference between the projected and the actual surface area, that gives us the indication about the roughness or slope of that particular surface. Other thing which is possible, we have graphical information or spatial information about the different facilities or utilities which lying in the surrounding of a particular building which is to be constructed. If we have the information about the surrounding in some other databases, those databases can be linked with the graphical or attribute information which are there in the GIS. So different types of spatial analysis or non-spatial analysis on the databases which can be linked with the database we have in the GIS are possible. If let's say we have surface or virtual surface in GIS, so we can draw profile along a line. We will just draw a line, and that GIS generate profile. If we see, this is the surface of the particular surrounding. If we have drawn here, I have drawn a particular line, and GIS helps in generating profile along this line. Even sometime, let's say we we are interested in finding out contour along a particular line or along a particular point, or contour of a particular elevation. That is also possible, which is quite useful in identification of road. Then other type of analysis which are possible, that is to see from a particular point that which area is visible or which area is not visible. What is done here, we specify a location and height of point above that location. Then from that point we can see which is visible or which is not visible. If we say here the results, let's say this is the point, and this of location of point from where we are performing visibility analysis, then if we see toward this side, then the portion which is visible, that has been shown by this line green, and portion which is invisible, that is shown by the red line. So same way we can perform visibility analysis to see that which part is visible, which part of the surface is visible from the specified location, and which part is not visible. Another thing that is the runoff pattern. Whenever any construction is carried out in a particular location, there may be some changes in the topography. So GIS help in visualizing that how was the flow when the site was not disturbed, and how the flow will change when changes are there in the topography. So if we see here, let us suppose this is the site. If this is the location of a let's say a water tank. If let's say water comes out somehow from this water tank, then which is the route that is to be followed by that water to go out of that particular area, that can easily be calculated. If we see here, this diagram shows two surfaces. First one, it shows change in the flow pattern and profile along a line. First is that this is the natural topography, and if let's say this is the profile along line, this UV, and this arrow direction shows the flow pattern. But let us suppose this is the way. Here if we construct some building, now we see that because of this expression, flow pattern changes. So the water from the different sides comes into XY. So it allow water to come in. So this shows that how this change in topography affect flow pattern. Actually, this help in understanding how was the flow when how was the flow and amount of flow when it was unchanged. And if let's say we do some excavation or we do some changes in the topography, how that flow changes. And sometimes it also help in, let's say, drain out that particular site. If we see here, so how this water was drained out from the site. Here that on the two sides where flow was less, from the two sides, a retaining wall was constructed, and here a drain was constructed to drain out the site permanently. Other thing is the logistic planning. When different consignments from the different places come to a particular site, in that case we need to do some logistic planning. We need to find shortest path or best path, or path which has least grade resistance. So in that case also GIS is helpful when consignment from different places are coming to a particular construction site. If let's say we take example, this is the it helps in determining the shortest route or low grade path where change in grade is less. So this shows the shortest path between the two locations. One is the entry point and other is the construction site. Other analysis which can be carried out, that is identification of ridges or streams. Generally, the base which is used, the cells with high flow accumulation in the raster grid are the area where concentrated flow take place. These are identified as a stream channel. The cell with zero flow accumulations are identified as ridges. So this concept is used to identify ridges and streams. If we see here, so we can easily identify the ridges and stream in a particular surrounding. This is quite beneficial in hill areas. And other analysis which we can perform, we can use GIS or that surface model to develop this drainage basin map. Drainage basins are also sometimes called watershed, catchments, or contributing area. So drainage basin is an area that drains water to a common outlet, and the outlet is the lowest point along the boundary from where water flows out of that particular drainage basin. If we see the drainage map of the surrounding of that particular building, so we can easily see that drainage basin map is quite useful in locating new building or in the identification of site to locate new structure. The building located in a drainage basin require very heavy earthwork or retaining work. Any construction in a drainage basin require quite very good earthwork planning by balancing cut and fill volumes of that excavation or excavated material. If we see here, these buildings have been located on the boundary cut and fill or earthwork. Other application of that virtual surface model, that is the earthwork planning. So virtual surrounding is helpful for earthwork planning that helps during construction. For that we require two surfaces actually. Two surfaces, one surface which is the natural surface, other surface which is actually required finally to carry out construction or to locate building. So if let's say we do analysis for this case study building, so now this was the site where that particular building was to be constructed. So this is the first natural surface. Now after excavation we require this surface. So this is the virtually modified surface. So these are the two input to calculate that earthwork. So the results show where cutting is to be done, where filling is required, where surface remain unchanged. So GIS helps in calculating the amount of cutting and or amount in terms of volume of filling and the surface where it remain unchanged. And it also helps in locating the depressions. Depressions are the points having elevation lower than the surroundings. If let's say water go into those depressions, that doesn't comes out, so those are taken as a dumping site. So once that the soil is excavated from the sites, that site can be dumped in these depressions. This is another case study building that we have taken, which has been placed on it in its surroundings. So it shows this this is the original surface. This was the modified surface. So these two were taken as an input. This is the output. Output where filling is to be done, where surface remain unchanged, and where cutting is to be done. And along with that, it also calculate the volume of cutting filling that is required. And surrounding to this particular construction site, we have identified what are the dumping, where are the dumping sites, so that let's say if excess of cutting is there, so that cutting can be dumped on these dumping locations. This is the reference for this analysis. Now another application is direct sunlight. It's a actually 5D phenomena. In which it occur in 3D, and in addition to three dimension X, Y, Z, we have this annual and day-wise cycles. Therefore, we call it three-dimensional, sorry, 5-dimensional phenomena. So 3 dimensions of space and 2 dimension of time. So these are the two angles which are important whenever we talk about this direct sunlight. So these are altitude and azimuth. So we all understand this. So we will not go into detail. And building is placed along at any orientation, and it can be analyzed for direct sunlight visualization. So it require input of time, that's hour and minute second. So this is the input for time. Then this second was the dimension of time, was that date, then its location and reference latitude. So if let's say we give input, then that this program in JS calculate sun angles, and those sun angles are used. Sun angles mean azimuth, and altitude angles are used to calculate the amount of sunlight received by a particular surface. If we see the output, this is the very small building taken as a case study. Now the time as well as this location and date has been specified here. So if we see here, this is the east side. This face is receiving more sunlight. When time is around about 12, then the sun is over the building, so that these horizontal faces are receiving more sunlight. When it's 2 p.m., in that case, sun start going toward this west side. So this face of this particular building is receiving light. And when time is 5 p.m., then that sun goes toward the west, so this face is receiving more sunlight. So in this way, this JS helps in understanding that how to orient a particular building to get direct sunlight. Other important conclusion that we can draw, if let's say this is the north side, south side. So south, if we see here again, south facing walls attain more solar heat gain during winter, when actually it is required in the northern hemisphere. And south facing walls attain least heat in the summer, and with least in summer mean less heat when it is not required. So that we can say, we can draw very good conclusion that south facing walls are desirable in the northern hemisphere. Other thing, that if we see the sunlight direct sunlight animations are used to see that that how here horizontal surfaces receive more sunlight when they are not required. When it is not required, see on the 5th of January, when it's the winter season in the northern hemisphere, horizontal surface is receiving less sunlight. If on the 5th March little bit it has increased, but when in the summer around about 15 May, it is receiving maximum sunlight, which is undesirable. So this sometimes helps actually in locating a building in a given locality. Other thing or other area in which GIS is helpful, that is the quantity takeoff. So whatever we dwell, whatever 2D drawings we have, that those drawings can be converted in the form of layers, and these layers can be act as a input in GIS to develop quantity takeoff. This is the procedure that has been developed, but right now we are not going into detail. But these layers which we have developed, these layers are used to generate bill of quantities. So output will be in this form. So we will find here that how GIS is helpful in calculation of quantities of different items of work. So that's mean that 3D models that has been developed for visualization that can also be used for quantity takeoff, and this quantity takeoff is quite precise, and it mainly depend upon the dimension of those features which we have represented in layers. If dimensions are correct, then estimates are correct. So now this GIS can be used to develop this database in GIS for cost estimation also, to make that to develop estimate of unit cost. So and that unit cost database we have, and we have the quantity of different items of work. So it can be used to both can be used to calculate construction cost actually. So this is the flow chart or flow diagram to generate bill of materials for different items of work, which have been represented in terms of layers actually. So database of unit cost of different items of work is useful for construction cost estimation. And but main thing that we have to keep in mind that this cost estimate work for repetitive works, because whatever that unit cost we have kept, that is based upon the past experience, and that work well for a particular geographic region. So that the accuracy of cost estimate, it depend upon unit cost data in the database. So this is more about, if let's say anyone is interested more about this, how to do this estimation in quantity takeoff and cost estimation in GIS. So this was all about few basic analysis or some cost estimate or sunlight visualization which we can do in GIS. Thank you very much.